Everybody, and welcome to my channel. Today I will solve several problems from FE Civil Engineering exam in mechanics. So problem number one, which condition must be met for a rigid body to be in static equilibrium? Now for static equilibrium, we know that summation of moments, summation of forces should be zero, and summation of moments should be zero. So the sum of forces must be zero. That's correct. The sum of moments must be zero. That's also correct. Both the sum of forces and the sum of moments must be zero. And only the net torque must be zero. So the correct answer is C. Next question. The moment of a force about a point is defined as. Now we know that the moment is force multiplied by distance. Now the distance should be the perpendicular distance between the force line of action and the point where we want to determine the moment. So if we have an object like this, for example, and we have a force acting on the object, if we have a force in this direction, this is F, and we want to determine the moment of the force at point A, for example. So the moment is the force multiplied by the distance. Now the question is which distance? We said that it should be the perpendicular distance. So this is the distance. This is D. So it is the perpendicular distance between the point and the line of action with the force. So the answer is the product of the force and distance along the line of action. This is not clear. The product of the force and the perpendicular distance from the point of the force's line of action. So this is the correct answer. The sum of the force, this is not correct, because it is not the sum. The ratio of the force to the distance, this is also not correct. So the correct answer is B. Next question. Let me remove these. According to Newton's second law, the net force acting on an object is equal to. Now we know Newton's second law states that force equals mass by acceleration. So Newton's second law is very well known law. So Newton's second law states that force equals ma, where F is the force, m is the mass, and a is the acceleration. So mass multiplied by acceleration. So this is the correct answer. So the correct answer is A. Now, if you are sure of the correct answer, then you don't have to go to the other options to save time. Now, the next question. For a block on an inclined plane that is on the verge of sliding, the maximum static friction force is given by. Now we know that the friction force is the normal multiplied by the coefficient of static friction. So if you have an object, if you have an object on an inclined surface, like if this is an inclined surface, and we have an object here, for example, I just want to show the forces acting on the object. So the forces acting on the object are W downward, the weight, if this angle is theta. So the weight can be analyzed into two components, W sine theta, parallel to the object, the surface, and W cosine theta perpendicular, W cosine theta. So, and there's also the normal acting upward. So the normal, in this case, normal equals W cosine theta. Now the friction force is and there's also the friction force. If the object is moving downward, so the friction force is upward. So the friction force equals the normal multiplied by the coefficient of friction. So the friction coefficient is multiplied by the weight of the block. So if it is an inclined surface, it is not the weight, okay? It's part of the weight, or it is the component of the weight. If it is horizontal, okay. But this is an inclined surface. So the friction coefficient multiplied by the normal force. So this is the correct answer. The friction force multiplied by the normal force. Next question. Again, let me remove these. So the question is, when calculating the resultant force of a uniformly distributed load on a beam, the resultant force is applied at. And we want to find the location of the resultant force. So if we have a beam with uniformly distributed load, or whatever type of distribution, if it is uniformly distributed, if it is a triangle, if it is a circle, the loading, so always the point of action of the load or of the resultant force is the geometric centroid of the load distribution. So here we have the choices are the left end of the load distribution. This is not correct. The right end of the load distribution. This is not correct. The centroid of the load distribution. So this is the correct answer. The centroid of the load distribution. So if the beam is like this, if this is the beam. Now if the load is, for example, uniformly distributed, so that's W, this is L, the span is L, this is W, weight per L, W per L per meter, for example. So if this is W per meter, so the resultant is WL and it acts midway. So this is L over 2. This is L over 2. So it acts at the geometric center of the load. If the load is, for example, triangle, so the resultant acts at the centroid, geometric centroid of the triangle, which is L over 3 from here. So the resultant force acts at the centroid of the load distribution. The next question, which formula is used to calculate the normal stress in a member subject to an axial force F with cross-sectional area A? Now the stress, we know that stress equals F over A. Stress is force divided by the cross-sectional area, and the force should be perpendicular to the area. So if this is the area, for example, or this is the cross-section, if this is the cross-section, so the force should be perpendicular to the cross-section. So then sigma stress equals F over A. Next question. Okay, next question. Let me remove these. So in material mechanics, which property is defined as the ratio of normal stress to normal strain within an elastic limit? So this is about the stress-strain relationship. This is the stress strain curve, very well known curve for civil engineers. So this is the strain, the x-axis is the strain, the y-axis is the stress. So this is the shape of the relationship between stress and strain for a ductile material, elastic material. Now the question is, within the elastic range, as the ratio between normal stress and strain. So we know the relationship is sigma equals E epsilon. Okay, and it's important to understand that this relationship is within the elastic range between the origin and here, point A. Point A is the elastic range. Elastic range means that there's no permanent deformation. If the rod is removed, the object will go to its original shape. There isn't going to be any permanent strain. So this is the relationship. So the ratio of normal stress, sigma over epsilon, sigma over epsilon equals E, which is the modulus, Young's modulus of elasticity. So the answer is A. Next question. Again, next question is about stress strain diagram. So Hooke's law states that within the elastic limit, again, we are talking about the elastic limit, stress is directly proportional to strain. Okay, which equation represents the relationship? We just said that the relationship between stress and strain within the elastic limit is sigma equals E epsilon. Sigma, which is the stress, equals Young modulus of elasticity multiplied by the strain, which is epsilon. So this is known as Hooke's law. So this is the relationship between stress and strain within the elastic limit. The next question, so the answer is A, sigma equals E epsilon. The next question, for a beam undergoing bending, the maximum bending stress at the extreme fiber is determined by which expression? So when a beam or an object is under stress or under moment, this moment causes stress. So the relationship between the stress and the moment is MC over I. Okay, sigma. Sigma equals MC over I. This is a very well-known formula in determining stress. Let me just explain this formula. So here if we have a cross section, now the stress varies along the cross section. If we have a rectangular cross section, for example, if this is a rectangular cross section, and this is the center line of the cross section. So the stress of this member is subject to a moment M. So the stress changes along the cross section or across the cross section. Okay, so according to MC over I, where C is the distance from the center line upward or downward, and I is the moment of inertia of the cross section. Now, stress is maximum at the outer edge of the cross section. So if this is H, if this is H, the depth of the cross section, so maximum stress is M, C is H over 2 divided by I, which happens here. Now, stress at one side is going to be compression, and at the other end is going to be tension. Okay, so there's going to be compression and tension. The upper side is going to be tension, and the bottom side is going to be compression. So the formula is sigma equals MC over I. So this is the correct answer. Now the next question. So the factor of safety in design is defined as the ratio of a material's yield strength to its working or allowable stress. It is the yield strength to its allowable stress. So the question is about just expressing this in a formula. So we have different options, A, B, C, and D. So A is factor of safety, yield strength divided by allowable stress, the yield divided by the allowable, as stated in the question. So the correct answer is A. The next question, what a simply supported beam subject to a uniformly distributed load? The maximum bending moment at midspan is given by. So for a simply supported beam, the maximum bending moment occurs at midspan, and the value of this moment is WL square over 8. You should remember this, okay, to save time in the exam. So if we have a simply supported beam, this is a beam simply supported, for example, it has a uniformly distributed load. Over its length. So the moment diagram is going to look like this. This is the moment diagram. It is 0 here, and maximum at L over 2. Now the maximum moment is W L square over 8. Now you can obtain this value by doing analysis, structural analysis, find the reaction here, and write the moment of equation in terms of X. But this is going to take you time in find the moment at L over 2, but this is going to take you time in the exam. So just remember the maximum moment is WL square over 8. This is for a simply supported, uniformly distributed load. So the next question. Now, in structural steel design, the term yield strength is defined as. Now, this is about the yield strength. So this is the stress strain diagram. Okay, this is the stress strain diagram for an elastic material like steel. So the yield strength, so now there are different important limits on this diagram. Point A is the elastic limit. Point B is the yield point. So the question is about point B. And for example, point E is the ultimate stress. So point B, the yield point, it is defined as the point where stress or deformation beyond this point start to be plastic. That means if the load is removed, there's going to be still deformation there. So the yield point, this is a definition. So the yield point is the stress at which a material begins to deform plastically. So this is the yield point, which is here, point B. So the yield point is the point at which the material starts to deform plastically. That means if stress is applied, if the load is removed, the object will not go back to its original state. The next question, so the answer is B. The next question. Okay. which load combination is typically considered in the ultimate limit state design of structures. Now we know that the loads considered in structural design are the live load, the dead load, and the wind load. So the answer is B. Now, in reinforced concrete design, the primary purpose of steel reinforcement is. Now, why do we add steel to concrete structures? Now we know that concrete can stand compression, but it cannot stand tension. So we add steel to resist tension forces or tensile forces. So the answer is B, resist tensile forces. Because concrete can withstand or it can resist compression, but it cannot resist tension. So we add steel to take care of the tensile forces. So the answer is B. The next question. In a beam theory, the differential relationship between the distributed load W, this is about the relationship between W shear, which is V of X, and moment M of X. Now there's a differential relationship between these three elements, W, the load, the shear, V, and the moment. Now the relationship is that the W, the weight, is the derivative of the shear, the negative of the derivative of the shear, and the moment and the shear is the derivative of the moment. So the answer, if we look to the choices, we see that the answer is B. The answer is B. That's dV by dx, the derivative of the shear is the negative of the load, and the derivative of the moment dm by dx is the shear stress. The next question, for a simply supported beam under a uniformly distributed load, if the load intensity is increased by 50%, how does the maximum bending moment change? Now we still have this formula. Now we see that the relationship, the question is that if the load is increased by 50%, how much will the moment increase? Now we see from this formula, the relationship between load and moment, this moment in maximum, is linear. The relationship between the moment and W is linear. So if W increases by 50%, that means the moment will increase by 50%. So it increases by 50%, so the correct answer is A. If the load is increased by 50%, then the moment will also increase by 50%. And this is because the relationship between the load and the moment is linear. So the next question. What is the primary purpose of drawing a free body diagram in a structural analysis? So why do we draw free body diagram in structural analysis? We draw a free body diagram in structural analysis to see or to identify all the forces acting on an object and their point of application. And this will help us solve the problem in hand, whether it is static or dynamic. So to identify all external forces and moments acting on a body, to calculate the cost, this is not correct. To design architecture, this is not correct. To determine environment, this is not correct. So the correct answer is A, which says that to identify all external forces and moments acting on a body, and I will add also their point of action. Not only identify the forces and its point of action. The next question. For a particle in a static equilibrium subject to three non-collinear forces, which condition must be satisfied? So if an object is in static equilibrium, so the forces must be parallel, subject to three non-collinear forces. So to be in Static equilibrium, the vector summation of the forces must be zero. So the forces must be parallel. No, this is not correct. The vector sum of the forces must be zero. So this is the correct answer. The sum of the forces magnitude must be zero. It is not only the magnitude. We also have to look at the direction. The forces must be equal in magnitude. This is not correct. So the correct answer is B. The next question. When a force is applied off-center on an object, creating a moment, the magnitude of the moment is determined by multiplying the force by. And we saw some similar question. Now, the moment is always the force multiplied by the perpendicular distance between the line of action of the force and the point where we want to determine the moment. So the distance along the line of action from the point of application to the center of mass. This is not accurate. The perpendicular distance from the center of mass to the force line of action. So this is the correct answer. It should be the perpendicular distance. The other two choices are not correct. So the next question. The rotational kinetic energy of a body is in constant angular motion, depends on. Now this is about kinetic energy. So let me define or write the definition of kinetic energy. So if an object is in angular motion, rotational motion, so you want to find an expression for its kinetic energy. So we know that kinetic energy, the definition of kinetic energy is kinetic energy equals half mv square. This is the definition of kinetic energy. Half mv square, where m is the mass and v is the velocity of the object. Now the relationship between v and rotational velocity, v equals omega r. The velocity equals omega r, where v is the linear velocity, omega is the radial velocity, and r is the radius. Now v square equals omega square r square. So kinetic energy, we substitute v square half m omega square r square. So this is the kinetic energy in terms of omega. Now we know that omega, the mass multiplied by r square is the moment of inertia. Mass multiplied by r square is the moment of inertia. So the kinetic energy is dependent on the moment of inertia and the square of the angular velocity. So we see that the moment of inertia and the square of the angular velocity. So the correct answer is C. So that's all for today. If you have any question about the problems solved in this video, please leave me a comment. If you have any question you need help with, please also send me in the comments. Thank you for following my channel, and I look forward to seeing you in the next videos.